Hello, everybody. In this video, we are going to talk about different random sampling methods. Um, there's a couple that we're going to talk about. So we're going to talk about simple random sampling, and then we are going to talk about stratified sampling and cluster sampling. So let's go ahead and jump into it. So in the last video, we talked a little bit about bias, right, and bad sampling, right? Remember, our goal as statisticians is to figure out the truth, right? So the methods that get us closest to the truth, right, or the true population values is when we use random sampling. Okay, the purpose of sampling people, individuals, whatever it is that you're sampling randomly is to avoid bias, right? Due to some choice by either the individuals in the sample or by the scientist who has created the study or is running the experiment, right? And some of those biases are invisible, right? There may be unknown biases that we have. So in order to avoid those biases, we try to cancel them out or eliminate them by using random sampling. Okay, so what we're doing when we sample randomly, the actual definition of it is here, right? Random sampling is using a chance process to determine which members of a population are included in the sample, right? So we're not going to pick people. We're going to use some random method in order to choose individuals for our study. Okay. The most common type of random sampling method is called simple random sampling. So simple random sampling. Most of the time we abbreviate it as SRS. Okay. And the definition may be a little bit counterintuitive, or rather not what you would expect it to be. Okay. So a simple random sample is a sample of individuals that we select at random, okay? But the actual definition of it is that we choose samples of size n, so meaning of size 5 or of size 20 or of size 100 million, right? That's a ridiculous number, but you know what I mean, right? So every simple random sample has some size n that you as the statistician get to choose, right? Bigger is often better, right? The larger sample size you can get, the more accurate your data will be, right? Just because you're gathering more information, okay? The way that simple random samples are chosen, right, or the way that they are designed is that every individual group of n individuals in the population has an equal chance of being selected. So not every individual, like every person or every item, has the same chance of being chosen. It's that every possible combination of those individuals or products or whatever it is that you're sampling has the possibility of being chosen. Okay, so that's what this means right here. Every group of n individuals has an equal chance of being selected. That's the formal definition of a simple random sample. Okay, but the definition is sometimes a little bit more complicated than what you actually do. Okay, so here's a couple of ways that you can do simple random sampling. So the most common one that you've probably heard before is what I call the hat method. So if we were sitting in class and I wanted to draw 5 people's names at random, I would have you all write your names down on a little slip of paper and put it in a hat, and then I would shake the hat up to shuffle everything, and then I would pick 5 names at random, right? So I would pull a page out, read the name and put it to the side. I wouldn't put it back in the hat, right? Because I don't want to pull the same people twice, right? That's called sampling without replacement, meaning once I pull someone from the population, I'm not going to put them back in the population to be pulled again. Okay, so the hat method is when you draw n slips from a hat for a given population. I can't spell here. Okay. Right, but you have to have make sure everyone has a slip, right? Everyone in the population's name or identifier has to be in the hat somewhere. right? Not the most efficient method, okay? So the one that we typically use and the one you'll see the most common is when you give each member of the population a number, right? So number the population and then randomly select n number of people, right? So if we were sitting together in class, I would give you all a number from 1 to 22 because there's 22 people in our class at the time that I'm filming this, or the time that I'm recording this. So then I would use a random number generator after that, or a random digit table or something like that in order to select, say, 4 numbers at random, right? And whoever's number I call is included in the survey. Okay, so 2 ways that you can do this, 2 tools you can use to do this are using a random number generator, which typically you'll find on a calculator, or maybe online, right? Or you can use what's called a random number table, which I'm going to show you an example of in a second, but it's exactly what it sounds like. It's literally just rows and rows and rows and rows of random numbers, okay? Now, I know for right now, since we're not at the school at the moment, the ability to select random numbers on our calculators is not as important. But if you have to do this on the AP test, right, and you need a calculator to do it with, I want to make sure you know how to do that. So, and once we get back to school, I'll show you like we'll actually get to play with the calculators and record this. So the path for selecting a simple random sample on a calculator is you do menu, you type probability or click the probability button, then my thing is not letting me draw arrows. I may have to add them in later. I'll just use commas for now. So probability, then you press random, and we want to draw random integers, okay? And then what shows up is something that looks like this, right? There's something over here that looks like this, rand int 1 to 20. So those are the two inputs. So it's selecting a random integer from 1 to 20, okay? All right. The other way that we can select random numbers is through using a random digit table, okay? And this, again, will make a lot more sense if you can actually see it in action, okay? So basically, random number tables look like this. You can kind of see it on the right side of your screen here. It literally is just rows and rows and rows of random numbers, okay? So same method for when you would do this with a calculator. You start by giving each member of the population a number, right? And the goal is to use as few digits as possible, okay? And here's how you do that. So let's say, actually, I'm going to do this. I'm going to do this on this side over here. So let's say that we have a population of 100 people. Right, that's our population. We have a population of 100 people, and I'm over on the left-hand side on the slides if you've lost where I am. Rather than numbering everyone from 1 to 100, like 1, 2, 3, dot, 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 all the way up to 100, right? If I do that, then when I read the random number table, I have to read the numbers up to 3 digits. So meaning this 1 is actually 001. 2 is actually 002, and so on up to 100. So rather than do it that way, because you're having to use 3 digits, which is kind of a pain, instead, I'm going to label everyone from 0 to 99. So 0, 1, 2, dot, 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 and that puts me up to 99. That's still 100 people, right? And they all have 100 labels, but now I only have to use 2 digits, right? So I'm using as few digits as possible. So my numbers would actually be 00, 0, 1, 0, 2, dot, 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 all the way up to 99, okay? Then, okay, so that's step 1, give everybody a number, or every individual a number, and then step 2 is to randomize. So on the random digit table, you pick a row, any row that you wish, okay, and you read the numbers in groups depending on how many digits you have available to you. Okay, so here's what I mean by that. I'm over on, actually, I think I can erase this and then I'll do it on the left side of your screen here on the slides here. Okay, so here is a random number table. Okay, and you also have this in your notes on the right hand side here. Okay, so I have 28 hotels here. So they started at 1 just because we only had to get up to 28. So it doesn't really matter that I started with 1. They could have also started with 0, 0 if they wanted to. Okay, so here we're trying to choose an SRS of 4 hotels. So they just picked a random row in the random digit table, okay, which I will post for you all in Canvas. There's some like helpful like diagrams and tables and things that we use a lot in statistics. So I'll post that as a module in Canvas for you shortly. Okay, so here all of my hotels have 2 digits. So what I'm going to do is I'm going to read this random number table 2 digits at a time. So my first number is 69, which is not a number that I can choose. So I'm not going to use it. So then I'm going to go to my next one, 5, which is a hotel I can choose. So I've chosen this hotel, Beach Castle. Okay. Then next, I have 1 and 6, 16. So even though there's a space in between these, that doesn't really matter. It's just there for formatting, right? So you, like, the space doesn't matter. So my next number would be 16, which is a number that I can choose. It's one of my available hotels. So that's my second one. Then 48, not a number that I have available to me. 17 is a number that I have available to me. So that's my third hotel. Okay, if I keep going, I have 87, not a number I have available. Then I have 17 again. Now, here's the issue. 17 was already chosen, so I don't want to choose it again. I don't want to sample it twice. So because I have a repeat, I'm going to skip it and ignore it, okay, and go on to the next number. So 40 comes next, too big. 95, too big. This table or this row apparently really likes the number 17 because we have 17 again. Can't use it because it's already been chosen. So I'm going to keep going. 84, too big. 53, too big. 40, too big. 64, too big. 89, 87, 20 is the one that I come up with. That's my last one. Okay, so 20 is my final hotel that I'm choosing. Okay. Here's my advice, y'all. If you have a calculator available to you, it's usually better and faster to use a calculator. But sometimes on multiple choice questions and things, they'll just give you a random digit table or like a row like this from a random digit table and ask you to select, 3 or 4 individuals from a population list. So it's good to know how to use it, even if you don't think you're going to use it very often. All right, so that's a random number table. Okay, so all of this, again, is ways that we can do a simple random sample, which is the most common type of sample or random sample because in its name, it is simple. It is the easiest, okay? So there are 2 other types of sampling methods, though, that we need to know about. Okay, 3 technically, but we don't use systematic samples very often. Okay, so let's talk about these other types of sampling methods. So a systematic random sample is exactly what it sounds like. You have a system in place where you choose every 10th person, for example, right? Or every fifth person or every 18th pencil or whatever it is that you're sampling. So you start with a random individual, right? And sample every nth individual after that. So that would be like if you were if you were on the street or like in a crowded area and um, you were trying to get people to answer a survey question for you, you would maybe start with the first person that you see walking by and then count and say, okay, every fifth person that I see walk by me, I'm going to ask them this survey question, for example. Okay, so that's a systematic sample. Next, stratified random sample. So here's how stratified random samples work. You start by classifying the population into groups of similar individuals. Okay, and we call those strata. Okay, then what you do is you choose a separate simple random sample in each strata, each group, right? Each group of similar individuals, and combine those smaller simple random samples to form the complete sample. Okay, so you may be thinking, that sounds like a ton of work. Why would anyone do this that way? Okay, here's why, right? The key thing here is that it's more precise than just a simple random sample. Okay, in a simple random sample, every possible combination of people has the same opportunity to be chosen. So if we're asking a very polarizing question, um, that different groups of people in a population may have a different opinion about. So I use politics a lot of the times because that's sometimes the easiest like division of people, right? That isn't like gender based or race based or something like that, right? So if you're asking a very polarizing question, right, and you just do a simple random sample, right? Say you're asking a question that about universal health care, right? And you have one group of people that are all for universal health care, and then another group of people that are against universal health care. If you do a simple random sample, it's possible that everyone you pull from the population will be in one of those groups, and you would exclude the other group just by chance, right? Just because of the natural variability of random sampling, right? And the natural variability of the world, right? That would alter your data, right? And it wouldn't be a true reflection of the opinions of the people in the entire population. So if we take a small random sample from every group that we think might be different, right, or might have different opinions, then we'll make sure that we've covered or gotten opinions from every subset so that we're not excluding anybody. Okay, so the way that I like to describe this to students, the most accurate way, is that when you're doing stratified random sampling, you are taking some, so a small sample, from all possible groups. Okay, some from all. Okay, so that's a stratified random sample. Right? A cluster sample is a little bit different. Okay, so for cluster sampling, here's what you do. So you start, instead of putting people in groups that are similar, where everybody in the group has something in common, so you start by classifying the population into groups of individuals that are located near each other. Right? and those groups are called clusters. Okay. The goal for the clusters is that they should be mini versions of the entire population. Okay. So here's why. Okay. So once you classify the population into these clusters, then you select a simple random sample of clusters and sample each individual in the clusters you select. You randomly select. Okay? So rather than taking a couple of individuals from each group, you're going to divide the population into groups, and then you're going to sample everyone in the whole group if that group is chosen. Okay, so again, you may be thinking, that seems like a lot of work. It seems so much more complicated than a simple random sample, right? But in actuality, they're more efficient than simple random samples. So just because they're easier to do, right? And here's the thing though, I don't want you to confuse this with a convenience sample, because it sounds almost like a convenience sample, right? Where you're like, well, I'm just grouping people together who are close to each other, and then I'm just going to sample everybody in the group. That sounds like a convenience sample to me, right? But these cluster samples are valid as long as you select the individual clusters at random, right? That's where the randomness comes in, right? And that's what makes cluster sampling valid, right? And I have this lovely drawing down here that kind of illustrates visually what's going on. So let's say each of these 6 boxes down here for the cluster samples are rooms full of people, right? And let's say I'm standing right here. Here's me. I'm the statistician, and I'm over here with my crazy hair. Okay, and I'm standing right here. So if I just go in and decide, well, I'm going to sample this cluster and this cluster because they're closest to me, right? If I decide that, that is a convenience sample. But if I say instead, right? Okay, instead of doing that, instead of choosing my samples, I'm going to say, okay, I'm going to number, let me make this a little thicker here. I'm going to number each of these rooms from 1 to 6. So 1, 2, 3, 4, 5, 6. And then I use a random number generator to select 2 random numbers from 1 to 6. And then I go in and sample those clusters, the ones that I choose. That is a cluster sample, right? I introduced randomness. It's not a convenience sample. Okay. All right. So the summation of what a cluster sample is you're taking all, meaning everyone, from some groups. Okay, you're taking all from some. Okay, and I really do like this this graphic, right? That kind of describes this, right? Um, so you can see in a stratified sample, right? See how all of the dots have the same colors, right? All the dots that are grouped together have the same colors: red, black, blue, orange, green, purple, right? So indicating that they are similar in some way. The individuals in each of these groups, right? Each of these strata are similar in some way. And I took a simple random sample. I selected a couple of individuals at random in each group. But with cluster sampling, see how everybody is different, right? All of these colors are mixed in clusters, right? So each one is a mini version of my population. Then I'm going to select and sample everybody in the clusters that I choose. Okay. So there's an example here that I think sums this up pretty well. and gives you a real world example with something that's a little bit more maybe familiar to you all. Okay, so here's an example with dealing with strata and clusters. Okay, so if we were physically in school, right, let's say Stuco wants to conduct a survey at our first all school assembly, right, about how students use the library. And they want to announce the results at the end of the assembly. So they don't have a whole lot of time to do this, right? And there's 800 kids at the assembly. Okay, so a simple random sample would be really difficult for me to do here, right? It would be very time consuming. It would take a long time, right? Because there's 800 students at the assembly, right? And all the seats are numbered. So I would have to pick 80 seats at random if I did a simple random sample, right? And then after that, I would have to go and find those 80 seats in the big room full of 800. That would take me a long time, right? To go find them and then ask them the question and then, compile all the data. Okay. So it may be easier for me to do either a stratified sample or a cluster sample. So in this assembly, I'm saying that the students are seated by grade level, right? And you can kind of see a picture down here. Um, so students are seated by grade level in this picture, right? And I'm going to go over to it here on this side, and I'm going to draw a little bit on the left side of your screen if you're following me there. Okay, so if you look at the key down here, I have all of my ninth graders in the seats 601 to 800, right? So they're kind of all grouped together. The 10th graders are 401 to 600, 12th grade 1 to 200. Okay, so you can see the way that these are grouped, right? I would have like my 12th graders would be up here, right? In this whole row, right, would be all of my 12th graders, and then it would go backwards, right? So then the 11th graders are behind them, then the 10th graders, and then at the very back, you have all the ninth graders back here. Okay, so if we wanted to do a stratified sample, remember the goal is to put people in groups, strata, based on their similarities. So I would want to group my students by grade level, right? And then I want to take 20 people at random. If I want to select 80 total, 4 grades, so 20 students in each grade, right? So within each seating area, I'm going to select 20 seats at random. Okay. The reason that I would want to do a stratified sample here is that we think, maybe we think that within each grade level, there's a similarity in how people use the library, like how students use the library. So maybe we're thinking freshmen have less work to do typically than juniors and seniors. So juniors and seniors may use the library more often than, say, the freshmen and sophomores. If we just do a simple random sample, it's very possible that my simple random sample would include only freshmen or only seniors, right? And if that's the case, then we won't get opinions or differences from the different levels of different grade levels. And if we think they use the library differently, then it's going to be important to get representatives from each grade level. But we're still selecting those representatives randomly, right? So doing the label the chairs from, in this case, it would be 1 to 200 in each grade level, and then you select 20 random numbers, right? So you're still doing this randomly, okay? All right, then, so that would be a stratified sample. A cluster sample here, if you look at the picture, if the rows are strata, the clusters would be the columns, right? Okay, so the columns could be used as a cluster because if you start at the front and take this whole column of students going from the front all the way to the back, then that means I'm guaranteed to get a representative from every grade level, right? Because I have all my 12th graders up here at the front, then the 11th, then the 10th, and the 9th. So in the column, you have a mini version of the population, okay? So it includes all of your grade levels, and this is the key, that it acts as a smaller version of the entire population, okay? So because each cluster has 40 seats in it, we would just select 2 clusters at random, right? So and that would give me 80 people, right? 80 individuals to sample. All right. Okay, so we're now at the point where I want you all to give this a try, right? See if you can identify in this next problem that's coming up the clusters and the strata, right? And maybe what advantages or disadvantages you may have from doing these different types of samples, right? And why we would use them rather than just doing a simple random sample, an SRS, okay? So I'm gonna give you a chance to pause the video. I'm also going to pause the video and write some of this out myself. So pause the video, give this a try, and then come back to it, and we'll see how you did. All right, folks, so if you take a look at the right side of your screen here, I hope you had a chance to try this out. I wanted to do an example for you of how to pick information out of a statistics problem, and to do that semi-quickly, because you have to do that typically pretty quickly when you're taking the AP test. So most of the time, the first sentence, they're just going to give you some background information, right? But you want to pull out the important information that they have in the actual problem and then interpret it, right? So we're talking about an NBA basketball game here. So we're in a huge arena with more than 20,000 fans, which is what I have highlighted in green right here. That's a lot of fans, okay? And then they're telling you that ticket prices vary a lot depending on how close you are to the court, which makes sense, right? If you're closer to the court, you can see better, so they're going to charge you more, right? And the top rows of the arena, which we usually call like nosebleeds, right? The nosebleed section, because you're really far back, those are cheaper, right? Which makes sense, okay? So what that means is that the rows are similar groups of people, right? Or that they paid the same price to come to the game, right? Then they've also divided the arena into different sections, which I'm sure you've seen if you've gone to any concert or like big sports game, right? Most of the time, those big uh, those big stadiums and things are divided into sections so that you can more easily find your seat, right? Okay, and they say that each section has rows of seats labeled with A to double Z. So really near the court to all the way in the back, okay? So those sections encompass everybody, right? The people who pay a lot of money to come to the game, who are at the front, all the way to the people that don't pay as much at the back of the arena, okay? Right? So that's the important information from the problem, and it'll make it easier to answer the questions that go along with it, okay? So the first question was, why would it be hard to get a simple random sample of 200 fans? Okay, if you think about a huge arena, if you've ever been to a huge arena, that would just take way too much time, right? If you're going to do a simple random sample, you would have to number every seat in there from 1 to 20,000, then select 200 of those seats at random, and then go find those seats in the arena, and then find the people who are sitting there and ask them this question. That would take way too long. So we're going to make our lives easier either by using a stratified random sample or a cluster sample. So number 2 asks, which of these groups should you use as strata for a stratified random sample? And they gave you 2 options, the lettered rows or the numbered sections, okay? So the key thing to keep in mind here, remember, is that in strata, the individuals should have something in common with each other that separates them from the other groups. So in this case, that's ticket price. How much did they pay to come to the game? So we want the strata to be similar groups of people, which we saw up here when we read this was the rows. Okay, so we need to choose the lettered rows for strata. okay, because each row is the same distance from the court. So the people in those rows probably paid the same or pretty similar ticket prices. Okay. So then for number three, we're talking about clusters. So clusters are the opposite. We want clusters to be very, or to have individuals in them that are very different from each other. The point of a cluster is to encompass the natural variability that occurs in the whole population, right? So in a cluster, the individuals should represent the variability in the population, right? So I don't want everybody that I pull in a cluster to have paid the same amount of money. So we're going to choose the sections for the clusters because each section includes all different seat prices from the people that paid a lot of money at the front all the way to the people that didn't pay as much money at the back, right? So essentially a mini version of the population. And then we would just pick a couple of those clusters and then sample everybody in the cluster. All right. So that is it. I know this was kind of a long video, but this is the bulk of studies, right? And how we create studies and sampling methods. Sampling methods is something that's really common that they ask about on the AP test. It's really, really common. So it's important that you understand what these different sampling types are for, right? Why we use them, um, and then how to implement them, because it's a very common thing that they will ask, right? Um, there's one more video after this one in this studies section, and that should be a shorter one. It's just on inference and a little bit more on bias. So I will see you all in the next video. Bye, everybody.